Hello everyone, how's life? This is Jacob, the 12th video of our C programming course. In this video I'm going to talk more about pointer and array equivalence as we talked and as I showed you in the previous videos. But in this video I'm going to show you some examples of the BJ document regarding to this actually concept. And also I'm going to talk a little about pointer arithmetic, which I also talked about a little in the previous videos. So let's go. The first thing you need to understand is this one, this expression here. These are equivalents. What does that mean? It means when we say the index B of the array A is equivalent as adding B times to the A's address and showing its value. So let's show. Let's do the same thing. Here I can say int numbers and declare some numbers 1, 2, 3, 4, 5, 6, 7, okay? And as I told you, I can have a pointer to numbers. Okay, let me check. Okay, and of course these are the same thing. So we get 1 with both of them because here we're indexing 0, which is 1, and here I'm printing the value of the PTR, actually PTR, the address that PTR is pointing to, okay, which is the first index of numbers per default, which is like this. Okay, the address of number 0. PTR is currently pointing at the address of numbers 0, which is 1. Okay, let's check something. This is good for you guys to see this. %p for pointer. And here if I say PTR and the address of numbers 0, let's see if we get something. So if you see, they're exactly the same. Okay, so you guys now can understand that after assigning this to PTR, they will be the same. So PTR is pointing to numbers 0, so they have the same address. Now the memory, why did I say it in Persian? the memory is like this. If I want to visualize it, because I don't have access to Paint here, I have to install something, GIMP or I don't know. So if this is the memory 0x1, if here is numbers 0, okay, so numbers 1 is in the next address segment. Look, it's like this. So if I say, if the PTR is here, okay, the PTR, if I say PTR plus plus, it will jump to here. So PTR will be here. It will point to here instead of the previous section. So let's see. If I say PTR plus plus, and now if I say so I get 1, 2, because PTR is jumping to the next step, to the next actually index. And that's not a lie. If I change it into, I don't know, 9, that's what you get. It will go to the next section, next segment. So here we can have nice programs like this. For example, I can say while the value of PTR is not equal to 7, PTR plus plus, and also print not yet. So it will just run and run until it gets there. So here I can add a condition like, I don't know, if the value of PTR is 7, simply printf what am I doing with my life with Vim. I can say 7 is here, okay, and I can break. So so 7 is here. If I add a 7 here, it will finish soon. And yeah, because here I'm incrementing the PTR, so currently it points to 7. When it gets here, it has nothing to do. I just need to stop doing this. Or it's a good time to show this one. Here we had PTR plus plus, and because it's the arithmetic method, I can say just PTR minus minus, so it will go back one address at a time. So 1 not yet, and 7 is here. And the other thing to show actually is that the address differs, you know. Here if we say the address of numbers, numbers of 1, numbers of 0, numbers 0, and PTR, and if I just copy that, let me just now here we incremented PTR, so let's see if it is the same with numbers 1, okay. So as you can see here, PTR and numbers index 0, they're the same, they have the same address. And also here they have again the same address because we're incrementing PTR. If we don't increment PTR, okay, and as you can see here, you know, DE4, DE0 and DE4, it's incrementing it by 4 bytes. You know, it understands that each integer is 4 bytes, so it needs to go 4 bytes further to reach the next integer value, okay, in the array. So if I just do this here, PTR minus minus, so here you can see that numbers 1 has this address which is 4 bytes further than the previous address, and these three have the same address because here I decremented the actually PTR, and now it's pointing to the first place it used to point. Okay, so here nothing changes. And another thing to show is that here we're saying that we have different kinds of indexing into arrays using for loops, and I want to show you this one here, which is the array notation, the pointer notation. So here I can just say simply for int I equals 0 while I is smaller than actually size of numbers, which I don't know. Here it says 5 because it counts them manually. So 1, 2, 3, 4, 5, 6, 7. Okay. So while it's smaller than 7, you know, I really love doing the size of matter, but here it's just okay. Just let's use 7 to reach the answer. So I plus plus. And here I have two ways to say. I can simply say person D. Let's just don't go to the new line. Person D. I have to go to the new line, by the way. Person D of what? Of numbers of I, which it's super simple. What am I doing with my life? So here I'm getting what? Let's do something strange. ANS. Let's cat ANS. Let's nano ANS. I'm doing weird, stupid things. Okay, here we get 1, 7, 3, 4, 5, 6, 7, and that's it. You know, here I can print the array like this. But also, another way to do is using the pointer. I can simply say that PTR plus I. Okay, why this happens? You know, here when we say PTR plus plus is actually adding 1 to PTR. So here is the same. When we say that PTR is pointing to numbers, which is 0, the 0th index, okay, is 1. So PTR is currently pointing to 1. Now, if I say PTR plus I, because I is starting from 0, when I say PTR plus I, it changes nothing. So PTR is still pointing to the same place. So it's going to print 1 for me. And the next round, when I is incremented by 1, so I is 1, I'm going to add it to PTR, so it means like PTR plus plus. So now it's pointing to 7. And the next time it's pointing to 3. And then 4 and 5. You know, that's how it works. The only thing I need to add here, and I don't need to forget, is the asterisk, F12, what the heck. The asterisk, because I'm saying that I want the address. So here in the parentheses, you know, because for the sake of priority, yeah, for the sake of priority, I'm using the parentheses. So here first it will add to the pointer and it will increment the address, the value of the pointer, and then it will print its value because of this asterisk here, you know, and that's it. So now let's go and see if we get the same result. GCC pointers and doing the same stupid thing and going like nano ANS, or we can do ls. Okay, 1767 17, what the heck, 173456, and that's it. It's actually working the same. So here when it says a index b is actually the same with the pointer notation, that's what it means. And yes, in the next video we're going to write our own mem copy. I think we have the program here. Okay, I'll show you in the next video. And also we're going to talk vast on void pointers. That's something like generics, okay? Not generics, but that's actually doing somehow the same under the hood, if you know generics. So thanks for watching this video, thanks for having me, thanks you for Thank you for being here, and yeah, have a nice time. See you in the next video.